Oh my God, the aliens are Swifties.
That's why they came here.
That's why they came. They couldn't get concert tickets on their world.
This is StarTalk. Neil deGrasse Tyson here, your personal astrophysicist. Got Chuck Nice on the line. Chuck, how you doing, man?
Hey, what's happening, Neil?
All right. This is a Cosmic Queries.
Yes,
this is so popular. I'm amazed just how many people like to listen to other people's questions, and usually they probably got some questions of their own.
Inquiring minds want to know.
And so this is a grab bag on any subject at all.
That's right.
Do we solicit grab bag, or is this just leftovers from other ones that were not grab bags?
No, well, we actually asked people, do they want to send us some grab bag questions?
Oh, okay.
Yeah, so there you have it.
We asked. Some of my favorite because they're so random, you know?
Yeah, well, that's what makes it fun, you know? I think they're hip to it, to that as well when you, when you see. Well, let's jump into it, shall we?
And these are Patreon supporters.
Oh, that's right. Yeah.
They have exclusive access to the question line here. And
well, you know, so many people were sending in questions that we've had to figure out a way to cull it down. And we figured the best way to cull it down is to also make some money. We said, hey, give us $5 a month, man. And you can ask whatever you would like. No, the truth is that, you know, we need support through Patreon. And we figure, why not make this a Patreon perk as a reward for the people who are so gracious as to support us. All right, here we go. This is Victor Ray Rutledge, who says, hey, Chuck and Neil, here's my question out of Texas, a truly weird space in the multiverse. Since humans can vaguely see infrared and ultraviolet radiation, what other things in the physical world do we just ignore since they have always been ignored?
Oh, beautiful question. So I write about this in, I forgot which book. Let me think.
Okay, that is the most humble brag I've ever heard. Oh my God. You're insufferable. You know, I wrote about this once, and I can't quite recall which one of my many publications where I placed this particular information.
Okay, I guarantee it's in Death by Black Hole and Other Cosmic Quandaries.
Okay.
But there's a chapter in there called Coming to Our Senses.
All right.
And it's all about the fact that we have our traditional five senses that we know and love. And consider that before science took on technology and engineering, why would you think that the world had stuff in it that you couldn't sense or see or touch or taste or feel? There's no reason to even have that thought.
Because it's all happening. I'm seeing it all. I'm touching it all. I'm feeling it all. I've tasted it all. What?
And
you're telling me there's a whole.
And if you're religious, why would God make you have all these senses and when you're practically blind to what's actually happening out there, right? So there was strong philosophical, cultural, emotional requirements that our five senses saw everything. Anton van Leeuwenhoek, Dutch optical lens maker, he had the sense. Ooh, do I get to say that now? He had the curiosity to say, I wonder what would happen if I looked at a drop of pond water in my new microscope. To even have that thought. It's just water.
Yeah.
Why are you looking at a transparent liquid? There can't be anything interesting there.
And that was the day that he stopped drinking water forever.
The footnote to
that
this.
Was the foot. That
they
was
found a dehydrated body in the corner of the closet.
He looked at that and he was just like, "Oh my God! Don't ever do this! Don't ever put this stuff inside of you."
He saw all kinds of creatures, and I love what you know what word he used to describe them?
No,
animalcules.
Animalcules,
prettily a swimming.
Prettily a swimming.
Oh my gosh.
That's actually.
So he wrote this up and sent it to the Royal Society, and they thought he was just pulling their leg.
Yeah.
Right. And they said, you know, okay, this is fun to read, but next time put down the gin before you write to us.
Yeah, exactly.
Step away from the bottle. And the good thing about science, among many things, is they can be skeptical of that report. Who wouldn't be? But you can go check it out.
Right.
Okay. You can build one of these yourself. You can look at your pond water. So the verification of an extraordinary claim is fundamental to the advance of science. So there's something your senses can't see. You have sight. So a microscope magnifies your sight so that you see things that were otherwise completely outside of your awareness.
Right.
And medicine could not have made the achievements it did without the microscope.
Without the microscope.
So it's not that God punished you for being bad and that's why you have this disease. Something bit you.
Right.
And there's a bacterium or a virus, and you can track the flow of diseases in this.
Right.
So, and not only that,
God still could have punished you with the bite,
Okay.
Could have let the animal bite you so that, you get what's coming to you.
Yeah. So we were off and running to the small and to the large, all of which you can't see. Okay. Let's keep going. In my book,
once again.
Shut up.
Oh, which was this?
Astrophysics for People in a Hurry.
Yes.
Which I think has some of this senses discussion in it.
Right.
I recount the discovery of infrared.
Right.
Okay. I think we have an explainer on that one? We might have.
It's one of my favorite stories.
Oh, yeah. Because he's looking at the spectrum. This is William Herschel. After Newton did his thing with the prism and the colors of the rainbow, just deducing that the colors of the rainbow are embedded in white light, freaking out artists of the day. But that's the physics of it. And he said, I wonder what temperature the different colors are. And so he put thermometers into the different colors of the rainbow projected on his table, but you need a control thermometer, a thermometer that just simply measures the air temperature without the influence of the colors. So he puts one off to the side of the red. And that thermometer measured a higher temperature than everybody else.
All of them.
So he's freaking out. And he says, I may have discovered light unfit for vision.
Wow.
Invisible light. And so go from then onward, when someone says, oh, I have a sixth sense, I don't even have that conversation because I say I'm a scientist and I have 12 senses. I can detect ultraviolet, infrared, X-rays, gamma rays, radio waves, microwaves. You can't. All right. I have tools. Oh, you can if you had these tools. I can also detect gravitational vectors, ionizing radiation. I can detect small things, big things, in things too far away for you to see or even notice.
Wow.
So the answer is yes. The universe brims with things outside of our senses, and modern science is okay with that because we don't rely on our senses to decode the universe.
Nice.
There it is.
Excellent.
All right.
This is Manoj Chug. And thank you, Manoj.
Completely can't be right, but go on.
No. That's he spelled it out for me. He goes, hello.
He did. Okay.
He goes, hello, Neil, and hello, Chuck. This is Manoj Chug. It's as in chug a beer, Chuck. So
nice.
There you go.
Okay. He's helping you out. You got fans out there.
Yes, exactly. That's a good man or person here. He says, I'm from Plainview, Long Island. I'm a recent entrant as a StarTalk patron. And although I've been a huge fan of you guys for a long time, my question is, with the recent success of Chandrayaan, India's unnamed moon mission to the moon's south pole, pulled off at a super low budget of just 75 million smackaroos. Do you see NASA collaborating with the Indian Space and Research Organization for future space missions, launching astronauts and payloads to the ISS, etc., as a more cost-effective option compared to SpaceX and other private agencies? So I love my man. It's just like, is India NASA's new dollar store?
Dollar store. So yeah, India. So our missions that do what India's mission would do would cost 2x, 5x, 10x what India. That's $74 million. That's a low budget action movie in Hollywood.
Isn't that something?
$75 million.
Wow.
Right. So we have a lot to learn about how they did it on the cheap. The issue here is not how cheap it is in the absolute, but how cheap it is for the government to have done it. So in our world, the government does it. It's expensive, as many things are when you do them first. Then you port it off to private enterprise that trims fat and this sort of thing. And so I don't know that if Elon had to put a satellite on the South Pole, whether he couldn't have done it for 75 million or even less.
Right.
But NASA can't do it for 75 or less, or they never have. So that's my first point. Second, the good thing about collaborations in space is everybody gets to do what they do best.
Right.
And you bring it together.
Nice.
Right? So if India can get you there on the cheap, but they don't have the experiment, but you have the experiment, or you just mix and match the international, you mix and match the best features of the international participants.
Right.
And the International Space Station is kind of like that. But that being said, competition also kind of works to stimulate innovation and achievement.
Right. So does profit. So does profit. Sorry.
Profit first.
Profits first. Remember.
So I don't see every country always collaborating. So that's more than what is necessary to keep the engine going. But when it makes sense to collaborate, yes.
Right.
And when I met with Prime Minister Modi of India, I asked him about the Artemis Accord, which is a document signed by modern spacefaring nations where they promise each other to share data.
Right.
To do this in peace as we advance the frontier. So if you share data, that's a form of collaboration.
Yes.
Right? So they go to the South Pole, they're going to see where the ice is first. They share the data. Now we retool our mission to the moon with humans. Now they don't have to look in the same way because that's already been verified. They can look in a different way or look in a different place.
Will they really do that? Because now water on the moon becomes a resource. And when resources are scarce, people get kind of sketchy.
That's true. I mean, are there going to be moon wars on access to the crater waters?
Well, yeah, because even though we said, there's an agreement that says nobody can plant a flag on the moon and say, this is ours, this is our territory, this is our... What you can do is take resources. So now if we can, if people are locating and finding ways to extract and utilize, especially water, because, and I learned this from you, water is what is the propulsion system to take you further into space.
Yeah. So you can, if you break apart the hydrogen and oxygen and then bring them back together, it's highly exothermic.
Right.
It's jet fuel, basically. No, not jet, rocket fuel.
Rocket fuel. Yeah. So now why? So if you got to find a bunch of ice up there, you're like, damn, we just found all this rocket fuel. I'm not giving this to the United States. Why would I give this to the United States? And by the way, Manoj says, dear Neil, my apologies on behalf of the anchor who recently interviewed you from the prominent Indian news network and kept referring to the far side of the moon as the dark side of the moon.
Told you.
Definitely, he is not a follower of StarTalk.
Ah, there you go. He saw that broadcast. Yeah,
he saw the broadcast. So.
Yeah, I did some major Indian press that day.
Yeah, very cool. Very cool.
And me and Modi were like that, No.
Yeah, that's funny. No, I saw that. You made some headlines talking to Modi. He called for you, so that was a cool thing. Yeah. It was a good thing what you said, though, talking about how the idea of the furtherance of scientific literacy in the pursuit of these lofty goals in space is great for the entire country and therefore for the entire world. Yes, I thought that was well said.
Right. The entire country would include the 1 out of 6 residents of India who are Muslim.
That's right.
And their Muslim children, and so, I worry that he's got that.
Yeah, he's got that tendency.
There's that Trumpist let's find an enemy so you can vote for me because I'm hard on the enemy. And that, in the long run, that's destabilizing. And I'd like to think that space can bring everybody together. That's all.
Yeah, exactly.
Hey, Neil, happy Sweet 16.
What?
This is your 16th book coming out, the one that we started working on together 2 years ago.
This? Well, thank you. Yes, it's my 16th book. Practically forgot about it because I've been very busy, and I guess it's coming out in a month.
Well, it's my first book, so...
Oh, sorry.
We got to do something.
Sorry. So I should be more excited that, okay.
Absolutely.
Lindsay's first book?
I may be biased, but I think this is your best one yet.
All right, let's go on to Cicero Artefan. And Cicero Artefan says, hello, Dr. Tyson. Hello, Lord Nice. This is Cicero Artefan from Toronto, Canada. I've heard a few people saying that maybe a more advanced alien would not even see us because we are just not advanced enough to be seen, just like we don't care about bugs and worms when we're building our homes. Is that really what you think? With all of our technological advancements, wouldn't aliens look at us and at least perceive us? We're able to do math. I mean, we know physics. We've been to space. I mean, that's got to count for something.
Man, listen, my boy's got. he's not getting to sleep at night on this one.
That's right. Cicero was upset. He thinks, well, what do you think? I mean, are we advanced enough to be at least interesting?
I allow the possibility that the answer to that is no. I've given this example before, but I'm going to put it right out here and fresh. So what animal is closest to us genetically in the tree of life?
Chimpanzees.
Chimpanzee, of course. 98 plus almost 99% identical DNA.
Almost, yeah.
All right. What's the smartest thing a chimp would do? Well, it could stack boxes and reach a banana. Okay. Yeah. If it sees a banana hanging from the rafters, it might do some rudimentary sign language. It will know what size stick to use to extract termites from a termite mound, because apparently they're tasty to chimps. All right. So these are smart things that a chimp does. So what do we do? Well, we have math and poetry and music and art and the James Webb Space Telescope, and we walked on the moon. So our urge is to say, what a difference that 1.5% makes. Well, that's your ego talking, because maybe the difference between stacking boxes to reach a banana and the James Webb Space Telescope is as small as that 1.5% difference in DNA. Just consider that. Okay. And here's how to do that. You ready? Imagine a species 1.5% beyond us genetically on the intelligence scale. What would we look like to them? We'd look like chimps.
Right.
We're 1.5% beyond the chimps, and we have a James Webb Space Telescope. Go 1.5% beyond us.
Oh, they got a Dyson sphere.
Dave, is anything we've done going to impress them?
No.
Really? And that's just what, make it 5%, make it 10%. At 10%, there is, I cannot imagine anything we would have done that would impress them.
No. I would say at 1.5%, we would still be somewhat interesting because we study chimps. Now, possibly we study chimps because they are also apes and we are apes, and maybe that is what causes our intrigue and our curiosity. But anything beyond the 1.5%, I mean, when you say 10%, I mean, if 1.5% is the difference between us and chimps, then 10% is unimaginable.
This is my point. So, yeah, and I love the analogy. You build a house, and do you concern yourself with displacing the ants? No. All right. Or do you concern yourself with any of the wildlife that's on the plot of land where you just put in the foundation? No.
Right.
So I cannot say with good conscience that a sufficiently intelligent alien would possibly find us interesting. And think of the ego involved in that too.
Yeah.
There are all the people saying, oh, the aliens are coming and they probed my gonads. Really? They care that much about you? Right. Really?
Yeah, you're not that sexy and they don't care that much. So there you go. Wow, that's very sobering when you think about it. And
I'm just trying to be honest. I'm not, I don't want it to be like that, but
it just says that if we ever are visited by aliens, that most likely they're just going to take whatever we have.
Yeah, and don't pull out your handgun and shoot at it. Right? That's not going to.
Clearly, yes, exactly. All right.
Now, if there's any thread of hope that I could offer here, it's that human knowledge and achievement is cumulative.
True.
So you don't have to invent calculus.
Because somebody already did.
You can use it, start there, and then invent something new.
Right.
So maybe it's not that we have some limit of our knowledge or our brilliance, and that's that. Maybe every bit of human achievement is a rung on a ladder that gets added that'll enable us to see farther and farther into this universe, into the ideas that comprise the universe. And if that's the case, then we are smarter as a species than we are as individuals.
Oh, there you go. That's nice. That's a good thought. I like that. All right.
Or the aliens come and they say, take us to your leader. And you say, it's that AI algorithm over there.
Right. Yes.
Go tussle with our algorithm. See if you survive that.
Or just take them to Taylor Swift and, same difference. Take them to Taylor Swift, man.
The alien go,
yeah, and believe me, the alien will be like, oh my God, it's Taylor Swift. Oh my God, the aliens are Swifties.
That's why they came here.
That's why they came. They couldn't get concert tickets on their world. So anyway.
All right, keep going.
Here we go. Stone Courier. Stone Courier says this. What a great name, by the way, Stone Courier.
But is it real?
Yeah, exactly. I mean, it's definitely a news anchor name. I'm Stone Courier. Says, hello, Neil. Hey, Chuck, I was looking for some information on space-time. What shape is it? I know our solar system and galaxy are flat disks. Does this mean that space-time is also a flat plane? Also, what is the deal with bending to matter? That's a strange way to interact with matter, don't you think? Thanks, guys. What's the deal?
All right, let me lead off with the opening quote of my book, Astrophysics for People in a Hurry.
Yep.
Do you know that opening quote?
Yes. The universe is under no obligation to make sense to you.
That's my answer to your guy.
Well, there you go, buddy. There you go, Stone Courier. There you go.
No, so matter and energy, which are the same thing,
right?
Their influence on the space-time continuum is to curve it towards it.
Right.
Okay. So the sun has space-time continuum curved towards it. Right. So all the planets are falling towards it.
The sun. Right.
Okay. But they have speed. They have a sideways speeds, which maintains their orbit. But if you take away the sun, they'll fly off at a tangent and never come back. So the dimple in the fabric of space-time is what contains all of the orbiting objects around the sun. So yeah, that's how that works. Like, deal with it. And not only adjust the fabric of space-time, the time coordinate is such that your time slows down in the vicinity of these concentrations of matter and energy. And so time goes slower for us on Earth's surface than it does up in high orbit, like a couple hundred miles up, where our GPS satellites orbit. Right. So they have a different time system than we do.
Right.
Yet, as I've said in another show, we get our precise time from GPS. So how's that possible if it's in another time coordinate system? Because we take Einstein's general theory of relativity, published in 1915, calculate how much faster its time is ticking and correct it before it tells you what time it is on your cell phone.
It still blows my mind, man. I mean, that is just, That alone should make everybody a fan of science. Just that fact. And the fact that the man figured it out in 1915 before there was any such thing as a calculator.
Or space travel.
Or space travel.
Satellites, right. Right. 50 years before anybody, 45 years before anybody went into space. Right.
Look at that.
So, yeah, and then people say, I'm just science. That's just my own. It's like, okay.
Yeah, what do I need science for? I have a gut. I got this gut, man. That's what God gave me this gut for. I don't need science. You and your calculations.
Yeah, I'll do what I feel. Yeah, we'll see how far that gets.
Well, that was great, man. Okay, let's go to Johnny G. Johnny G says, hello, Dr. Tyson and Lord Nice. Hope your day is going well. Easy name here for you, Chuck. Okay, thanks, Johnny.
And I'll write it in crayon so you can understand.
Exactly. I have a question that keeps me up some nights. What caused the universe to be infinitely hot and dense? Was there something before the Big Bang, or did the universe expand and collapse time and time again before our universe could come about? Also, what caused the Big Bang this particular time? Well, that assumes that there were other times. Thank you for your time and for the many laughs and for making learning so much fun.
I love that. Love that. So we devote a fair number of pages in the Cosmic Queries book, which I think is you can click by it on our website, startalkmedia.com. I think it's in there somewhere. If not, it's on my website if you can't find it anywhere else. And on my website, you have a choice of different vendors, right? If you don't want to, if you're anti-Amazon, there's like indie book sales and this sort of thing. So you have a choice. In there's a fair number of pages given to the origin of the universe and the best current ideas surrounding it. So to be very small, very hot, very dense, that is its birth state. It was burst into that state. So it's not how did it become that.
Right.
That's how it was born. And it has to do with this pocket of energy that slides into a configuration that has such extreme temperatures and densities where when you are that hot and that dense, you only have one thing you can do, and that's rapidly expand.
Right.
So now this mechanism that gives us our understanding of the Big Bang also makes other Big Bangs. So that's how you get the multiverse.
Right. Okay.
So you say, well, what time is it in this universe? Well, you can start the clock at our Big Bang, but maybe the multiverse has its own clock. And we came into existence at 20 minutes after 5 on a Tuesday afternoon. That's when we'd start our clock, but the multiverse might have a meta clock where it's cranking out the universes one by one.
Right.
So it has to do with these energy diagrams. I'm trying to explain this in the best way I can. What I want to give an analogy. So what would that be? If you have a hill, okay, right, if you have a hill that goes into like a little basin and it rains and all water collects in that basin, but wait a minute, that's not the lowest place that water can be,
right?
Because there's an even lower point on the other side of this little bump, okay? But this other water collecting there doesn't know that. It keeps building and building and building. It is possible for the water on this side of the bump to tunnel through to the other side of the bump. Quantum physics tells us that.
Right.
If it does that, then it falls to the bottom catastrophically. And that falling to the bottom is the birth of another universe.
There you go. That is...
It's crazy.
That's great. I mean, that's really cool stuff, man. But
right,
that gets super deep. I love it.
Right. Yeah.
All right, let's keep going. Let's go to Mark Armstrong. And Mark Armstrong says, hello, Dr. Tyson. Hello, Chuck. Why does the Milky Way look like a cloud when you look up at the sky? Shouldn't it cover the entire night sky?
Oh, great question. I love that. First, it looks like a cloud because you're stuck with human eyeballs.
Stupid
when Galileo, Galileo, with his newly perfected telescope, said, I'm going to look at the Milky Way. When he did this, he saw stars. So the cloud, while there are gas clouds in the Milky Way, the light that you see is coming from the puddled, merged image of light that you cannot resolve into the component stars.
Right.
Okay.
Right.
And even binoculars,
like an LED array. If you ever see these LED lights, it looks like one big light
from a distance.
But when you get up on it, you see, there's all these tiny little diodes, each one of them being equally bright to create this.
You calling them diodes? That's the third letter in LED stands for.
Diode, light emitting diode.
Yeah, you got it. You got it, Chuck.
So super cool.
Right. So that would be with binoculars or a telescope resolves the puddled light into individual stars. First. Second, the Milky Way is very flat. The spiral pictures you see of spiral galaxies, if you put them on their edge, they're not going to disappear, but they're going to become very not visible to you. Okay? I'll tell you how flat the Milky Way is. Flatter than a flapjack.
Than an actual flapjack.
Well, if you look at the ratio of the diameter,
ratio-wise,
I don't mean it's closer to a crepe, actually.
Oh, damn, that is
okay.
Thin.
So now let's put you inside that crepe.
Okay.
If you look horizontally around you, all you're going to see is crepe.
That's it.
But if you look above and below, there's not much crepe there to block your view because it's so thin.
But hopefully, there's some blueberry compote.
So the solar system is embedded in a galaxy crepe,
right?
And the galaxy, the Milky Way, is the plane of the galaxy.
Gotcha.
And when we look above and below, we're seeing outside of the plane of galaxies, and there's hardly anything there to block our view.
Look at that.
In fact, all data on all galaxies that we have in our catalogs come from looking above and below the plane of our galaxy because you cannot see through it. That's how dense the gas and stars are in our own Milky Way.
Wow. Cool.
Yeah, and by the way, this is true with blueberries and pancakes, right? So the blueberries always poking through the top of the pancake.
Right.
Always. And so if the blueberry said, what am I doing here? Hey.
All right.
I see the rest of the universe.
God, I am so hungry right now. Could I go for it? Crepes. It's been a while since I've had.
Yeah, crepes are fun.
Crepes are like fun. They really
pancake variant that you got to throw in there every now and then.
Yeah, man, it's always good stuff, you know. And they have the best toppings. Crepes, you know. Anyway, let's go to Peter Jacobs. He says, okay, wait a minute. I love it. Listen to this, Peter Jacobs. Listen to this. This one's for Chuck. Okay. If the vacuum of space spontaneously produces pairs of entangled quarks and Hawking radiation is where one of those quarks enters a black hole, can the remaining quark give us information about what's happening inside the black hole? You know what, Peter, you're a jackass, okay?
Chuck, just say yes to that question.
The answer is yes.
You came with that little bit of extra authority at the end of
it. Right.
Yes. So first, it's a brilliant question. I love it.
It is.
And in entangled particles allow you to know what the other particle is doing upon the measurement of a particle. Right. So the suspicion in this question is all the particles that went outside the black hole, orphaning their counterpart inside the black hole. Will it tell us what's inside the black hole? The answer is yes. Okay, except it's weirder than that. Okay, ready?
Go ahead.
The particles that pop into existence, these particle pairs, emerge from the gravitational field of the black hole.
Right.
The field. All right. So in this field, particle appears. One escapes, one falls back in. The black hole now weighs less than it did before because you just took away some of its gravity.
Right.
The gravitational energy became particles, and one particle escaped. If you inventory those particles that escape, they match everything the black hole has ever eaten. So the idea that a particle that escapes tells you what's inside the black hole, yeah, it is the precise inventory of everything in its digestive tract. Mm-hmm. So the black hole does not lose information. This is a famous bet between Stephen Hawking and my boy who worked with Interstellar, Kip Thorne, who got the Nobel Prize for his work on discovering laser gravitational waves using LIGO, Laser Interferometer Gravitational Observatory. So he's all in on this. So he made a bet with Hawking. What happens to the information that falls into a black hole? Is it forever lost? Then you run the calculation. The Hawking radiation recovers that information until the black hole disappears entirely.
Look at that. So information is not lost.
Not lost. And so, yes, and you're not finding out what's in there because of what fell in.
Right.
Just that moment. You're finding out what was in there that it had eaten long ago.
Look at that.
Yeah.
This is really great stuff. And
so when we say the black hole evaporates, it's not particles escaping the black hole.
Right.
It's particles being created out of
the energy of the gravitational field itself.
And that meant the gravitational field remembered what had fallen in the first place. And that's some spooky stuff.
That's really crazy, man.
Right.
That's super cool stuff. I mean, well, Peter, thank you for that question, even though you're a little bit of a jerk for putting it on me like that. No, we don't care. Okay, this is Patrick Weglinski. And he says, hey, Patrick here from Salt Lake City, Utah. Hello, Dr. Tyson and Lord Nice. If I were to go on a naked spacewalk, hypothetically, what would space feel like on my skin? Disregarding the fact that I would be unconscious in about half a minute, of course. And to my understanding, getting in a cold pool or going outside in the winter feels cold because of the molecules around me are spreading energy away from my body. In space, there's a lot less matter around you to draw heat away from you. And I think the only way to lose heat would be from the radiation of my own body, right? Would that be enough to really feel cold as a human popsicle cold like in the movies? Or could someone theoretically be comfortable for a short amount of time without a suit leaving their spaceship? Thanks.
I like that.
Yeah, okay. Look at that. He went all in.
All in. Okay.
Brought up the explainer that we did too.
My boy was all in on because we did temperature explainers.
We did the temperature explainer.
Yeah, so it's a note to self. Tell him to check out our temperature explainer where we talk about radiative cooling and heating and this sort of thing.
Exactly.
So, yes, there are no molecules to whisk away your body heat. And so you'll be completely radiative. Right. Yes. Your body heat will radiate away from your skin, and it will do it faster than your body can maintain its temperature. Right. And so you will die, then your body temperature will drop rapidly. So you could a few seconds. Yeah. This was correctly shown in the film 2001, A Space Odyssey. The guy came through the airlock without his helmet, and he's out in space, and in the vacuum of space, he hold his breath. Okay. Right. And which I don't think is the right thing to do because your lungs will explode if you do. The lungs have normal air pressure air in them. Right. Then you go to zero air pressure.
Right.
It'll just blow out your thing. Right. Yeah. So you want to let the air slowly
expel the air out.
come out of you. Correct. Right. And I think divers know this as well. Yeah. And so depending on certain diving conditions where the air in your lungs is compressed once you're already low. So as you come up, you can just exhale for longer than you thought you could.
Right.
Because the air is continuing to expand.
Right.
Yeah. So it's an interesting phenomenon when it happens to you. So yeah, I think you can survive a bit. I'm not going to do that experiment myself. But yeah. And now, why would you want to do this naked though? Because you've all heard what happens to your ears when it gets very cold out. Your ears will freeze and they'll crunch off like a potato chip.
Right. Well, I'm not worried about my ears.
Oh, that's what I'm saying.
Okay, I'm just saying. I'm not worried about my ears. Okay. Yeah. I got something far more important pops to mind. Just saying.
Just saying.
Just saying.
Just saying.
Just saying.
Just saying. Yeah. So I would be cautious of that.
Yeah.
But again, it's radiative heat that's leaving your body. Until your body reaches an equilibrium of the radiative energy that's coming towards you.
Right.
And so if you happen to be near a star, you could probably reach an equilibrium temperature that would be okay. But again, you still have to breathe.
You
Like
got to
there's no air
breathe.
out
So,
there.
yeah.
So.
Oh, man, that's so cool. Well, it's a fun thought experiment.
All right, let's get one more question.
One last question. Here we go. This is Julia Lind. Or Lindy. Yeah, she says, hello, Dr. Tyson, Lord Nice. What should be our biggest priority for exploring the solar system? Landing humans on Mars? Sending probes to Europa or Enceladus? Building a base on the moon? Or maybe something else? Thanks, Julia from Hatboro, PA.
Ooh, okay. Right. So I'm glad I can answer that with high authority and confidence. You ready?
Go for it.
Let's do it all. I will not tell people what they should do.
Right.
That's not what I do, even if it feels that way sometimes.
Right.
I'm here to try to enlighten people, to inform them, so that when you make a decision in a free country,
right,
where you vote for people who will go into space, you're as informed as you possibly can be. That's my goal. All right, so I'm not going to prioritize destinations in the solar system. What I will say is it's not all that expensive in the big picture.
Right.
Everything NASA's doing is happening with 0.4 of 1 penny on your tax dollar.
Right.
0.4. That was the DART mission to deflect an asteroid. That's the space station. That's the Artemis mission back to the moon, all of that.
Yeah.
All right, so, and that's 0.4 of 1%.
Yeah.
And I ask you, how much is the universe worth to you?
Ooh, look at that.
Yeah. So,
well,
that's what I ask. And so yeah, let's put people on Mars and mine an asteroid and lasso a comet in case we need some fresh water and figure out a way to deflect the asteroid that's headed our way. And and space tourism. Let's do it all of it. And then the solar system becomes our backyard, which is cosmically true, was always cosmically true, and then we'll make it a reality for our species.
Nice.
Oh, and by the way, and we want to look for life on Mars or on Europa. Yeah, let's do it.
Yeah.
And by the way, there are missions to do this, but they're bits and pieces, and it's not the backyard plan from NASA. That would be fun.
Nice.
And by the way, there's rare ingredients on Earth, like rare Earth elements that are common in space.
Yeah.
Okay. Energy is plentiful in space. There's a lot of things that are common in space that we're fighting over to gain access to here on Earth. And so space might be the greatest force of peace in the world for removing an entire category of warfare that's existed with us ever since we stepped out of the cave. And that's violence committed upon other tribes because of limited access to resources. There it is, Chuck.
Oh, man, that was a good one.
Man.
This was a great episode. Thank you, people, for all these great questions.
Thank you all for that. And like I said, if you want to be the ones who can ask the questions, that's just $5 a month.
That's it.
And I'm pretty sure nothing in Starbucks costs $5.
No. Yeah.
There might be hot water and a tea bag, I think, is less.
No, you're not getting that for $5. No. Maybe if you brought your own cup.
And your own tea bag. They give you hot water for $5.
There you go, $5 of hot water.
All right. So this has been Cosmic Queries, Grab Bag Edition. I'm Neil deGrasse Tyson, as always, bidding you to keep looking up.
Hey, we're bringing science down to earth. What is this, Neil?
This is Wheel of Science.
Hey everybody, I'm Chuck Nice. Welcome to our newest show, StarTalk's Wheel of Science. This is an interactive show where we answer your questions about the universe. And because I'm not smart enough to even answer my own questions about the universe, we have here to help out the one, the only, your own personal astrophysicist, Dr. Neil deGrasse Tyson. What's up, Neil?
What's up, Chuck?
As usual, you don't know the questions.
That's right. I'm sitting here clueless.
Aha, but I am positive that you know the answers. Our topic today is black holes.
Let's do this. Bring it on.
Hey, Neil, before we get into it, can you just let the people know, what is a black hole?
Black hole is a region of space where matter has condensed to such a high density that the gravity at its surface, the surface gravity, is so high that you cannot escape it, even at the speed of light. You are forever trapped. It is the fabric of the space-time continuum warped back on itself. And once you fall in, you are never coming out. It is the human version of the Roach Motel. You check in, but you don't check out. A black hole. That's why we call them black. And when you fall in, you don't come out, that's why we call it a hole. Because we tell it like it is in astrophysics. Black hole. Spin that wheel.
Daniel Junius wants to know, what happens when we fall into a black hole?
Ooh, you want to avoid that, first of all. Don't do that. Neither at home or at work or anywhere else. But if you happen to fall in a black hole, which is my preferred form of death, it's better than getting hit by a bus, right? So if you fall in a feet-first dive to this cosmic abyss, you will not survive because you will not miss. The tidal forces of gravity will create quite a calamity when you're stretched head to toe. Are you sure you want to go? Those tidal forces will increase to the point where your body will just snap in two, likely at the base of the spine. Then each of those two pieces will snap into two. So you become 1 to 2 to 4 to 8 to 16 until you bifurcate all the way down to the center of the black hole, and you become a stream of atoms. And that's not even the worst part. The worst part is you are funneled, extruded through the fabric of space-time, so that you used to be this wide, now you're this narrow. And so this phenomenon, this extrusion like toothpaste through a tube, we have a word for it. Death by black hole is called spaghettification.
Spaghettification sounds like a meal to die for. See what I did there? Kill me. But give this video a like for a dad joke.
Chuck.
All right, Neil, you ready for the next one?
Spin that wheel.
Ivica Stern wants to know this. There is a black hole in the middle of our galaxy. Is there a giant black hole or something giant in the middle of our universe and something in the middle of the multiverse if we follow that logic?
No.
And that's all we have time for.
No, what do you want from me? It's a no. No. No.
But I'm sure there's more to it. What's up?
There is no center of the universe. All the universe was in the same place at the same time nearly 14 billion years ago. Then you could think of it sort of as a center. But after that, we are expanding and all pieces expanding away from every place else. It feels like we're at the center, but we're not. Any more than when you're a ship at sea and you are in the middle of your own horizon. You're equidistant from every edge of your horizon. That doesn't mean you're in the center of anything. So no. There's no known center of the universe, and therefore I can say with some confidence there's no black hole there.
Okay, Neil, thanks for making me feel less important than I already do, knowing that I'm not the center of the universe. But wait a minute, how about black holes at the center of our galaxy?
We've got one, Andromeda's got one, except theirs is bigger than ours. We have black hole envy, but that's another show. Long ago, we didn't know if black holes would be common in the centers of galaxies with the help of the Hubble telescope, which has good, precise ways to look down in the center. Every galaxy we've had the capacity to check has revealed a black hole to us. Thus, we will extrapolate and assert that a black hole is a natural phenomenon in the center of all galaxies of the universe.
Neil, as usual, that's fascinating. We have time for one more question, and we're going to take a look at some group comments. But first, let's spin that wheel. Dan Birmingham wants to know, what's the most exciting thing we don't know about black holes?
There's good theoretical ideas about what would happen if you survive a trip through the black hole and come out on the other side. All of our equations tell us that an entire new space-time opens up for you. Once you've left the universe you were just in, you will never return to it, but you'll enter another domain. Our equations tell us it's there, but there's no way to test that and come back and tell anybody about it. So that remains, for me, one of the most intriguing mysteries of the universe. Is each black hole a universe unto itself? Chuck, back to you.
Damn, that is super cool. I'm gonna call that a black rabbit hole. Well, Neil, we are out of time. Thanks for being here, buddy.
Happy to be with you, Chuck, always.
Make sure you subscribe to StarTalk Network on Facebook Watch and join the Wheel of Science group and leave comments like Brian McReynolds, who says, I have just started sneaking science facts onto the dry erase announcement board at work, so this will give me some more ideas, LOL. Why don't you find Brian and leave him some facts, huh? Thanks for watching, guys. We'll see you next week on Wheel of Science.